So here we have an activity based on regulation, and in this activity we have to make some arrangements. Like we have a table, over that we have given some support, and over this support we have kept a ice slab. So the slab of ice has been kept over this support. Now we take a metal wire, a long metal wire is taken, and towards the two ends of the wire we have kept weights which are of equal capacity. The weights on both the sides are of the same capacity. And now what you have to do is you have to suspend this wire onto the ice slab in such a way that the two weights are on either side. Now as soon as you are going to place the wire containing weights, obviously the wire is going to exert pressure on the ice slab. Now wherever the pressure is being exerted, the melting point is going to be lowered. As per the rule, when the pressure increases, the melting point of ice decreases. So this is inversely related. Pressure and melting point in case of ice is inversely proportional. So due to the lowering of the melting point, the ice melts and converts into water. As soon as it converts to water, the wire sinks. But as soon as a wire sinks, the pressure is released in that area, and again the melting point goes back to 0. That is, it is restored back to 0 degree Celsius, which is the freezing point of water. So again ice is formed over there. But now the wire has sinked a little bit, so it is exerting pressure somewhere inside the ice slab. So melting point in that area decreases, converts the ice to water. Wire is going to further sink now. But moment it sinks, again the water refreezes. So this process continuously goes on taking place, and the wire keeps sinking and the water keeps freezing until the wire completely passes through the ice slab without breaking it into two pieces. So this is what is regulation. Here some important points have been listed. We will quickly read those points. As pressure increases, melting point of ice becomes lower than 0 degree Celsius. At 0 degree Celsius, ice is converted to water. So temperature goes below 0, where the ice gets converted to water. As soon as pressure is removed, the melting point is restored. That is, it goes back to 0 degree Celsius and water gets converted to ice again. And that is why we find that though the wire passes completely through the ice slab, it does not break it into two pieces. You all can perform this activity at home by making use of an ice cube, and what we can use is a thread. We can use a thread, and we shall apply pressure with our hands, and to a certain extent the thread does penetrate without breaking the ice cube into two pieces. So perform this activity and enjoy the activity. So in this slide I've taken up a few questions, like the very first one. In the above experiment, the wire moves through the ice slab. However, the ice slab does not break. Why? So the answer is that it is because of the phenomenon of regelation. Now you will be expected to explain the entire process, but I have not done it over here just because we have discussed it in detail. Is there any relationship of latent heat with regelation? So the answer is yes. What is the relationship? When ice melts, heat is absorbed, but temperature does not change. In the first activity, we did this, and we saw that when we provided heat to the ice cubes, they absorbed the heat. There was no temperature rise, and all the heat was utilized in breaking the bonds between the atoms and the molecules to convert the solid ice into liquid water. So when ice melts, heat is absorbed, but temperature does not change. When water refreezes, heat is given out, but temperature does not change. Now, When we carry out the reverse process, that is water we have taken and we are freezing it to form ice. At that time, the latent heat of fusion that was absorbed when the ice was converted into water is released, is now going to be released, and the temperature does not change at that time also. So this heat absorbed or given out is latent heat. So I hope you have followed this answer. That is, when you are converting ice into water, heat is absorbed, temperature is constant, and the heat absorbed is called as latent heat of fusion. But when we convert water to ice, we are converting water to ice, refreezing it. At that time, the latent heat of fusion that was absorbed by ice is going to be released. So this heat that is absorbed or released, that is called as latent heat. Is there relationship of latent heat with regulation? We have done this. You know that as we go higher than sea level, the boiling point of water decreases. I hope you know about this because we all have studied the functioning of the pressure cooker. The pressure cooker was very useful for high altitudes, hilly areas, because there the pressure is less and so the food is not cooked properly. So the pressure cooker, we take the contents of the food, in that we add water. Now, due to the steam that is created, the steam exerts pressure on the food items. So pressure is increased. So as pressure increases, the boiling point increases. The relationship you have to remember. That is, as pressure increases, boiling point increases. And now the food gets cooked properly. What would be the effect of melting point of solid? So the answer is melting point will decrease for solids which expand on melting, and melting point will increase for solids which contract on melting. Coming to can you tell? We feel that some objects are cold and some are hot. Is this feeling related in some way to our body temperature? So the answer is again yes. And how is it related? If the temperature of the object is lower than our body temperature, for example, ice, we feel that the object is cold. And if the temperature of the object is higher than our body temperature, then we feel that the object is hot. So these were some activity questions which I wanted to share with you. I hope you have followed this. Read the lesson thoroughly up till here, and soon we will meet in the next class. Till then, thank you.